We can look at derivatives of the y equals x squared function by using this derivative plotter. And basically what this plotter does is as I move this point C, it will show the tangent line at that point C, but it will also plot the actual value of the slope in red. So notice that as I go to the right, it's plotting y coordinates that are higher. As I go to the left, it's starting to plot y coordinates that are lower. And as I go towards the slope of 0, notice that it's hitting the y value of 0. So what it's actually doing is plotting the slope values. And by plotting the slope values, I'm actually getting the function which should describe how the slope changes as we move along this curve. So as we move along this curve, you can see that the pattern of the slope is actually a straight line. And when we actually find the slope using the definition of the derivative and the limit, we will end up getting a linear function as a slope function for this parabola. And we can show the same thing for x cubed. So if I graph x cubed, I can see that as I plot the points, the tangent points, so you can see that there's my tangent line. Okay, it's giving me slope values, and as it comes down, there it is. There's my slope values. Now it's quite steep, so the slope values are very high. But as I move this way, the slope is getting less and less, so the slope value, the red line, is coming down. It's coming down all the way to 0. So horizontal slope is going to touch y equals 0, and then as I go this way, now the slope's increasing again to the positive, so then it's showing it's increasing positive values of slope here, and it gives us this pattern. And in fact, when I graph this pattern, so this is the pattern that's giving me the slope. So the actual relationship is a quadratic relationship. So my slope function is actually quadratic. So if I find the slope function using my derivative, my definition of derivative of x cubed, I'm going to end up with a quadratic function as the slope function. Okay, so this what's happening here. And I can also plot 1 over x, so 1 divided by x. Okay, when I plot this graph, I get this function that looks like this. I'm going to just zoom out a little bit. And I can show again my tangent line. As I move that, my tangent line changes. And as the slope of that tangent line changes, I can make it plot out the value of the slope. So that red dot's plotting out the actual value of slope. It's negative slope. So notice that the red dot is in the negative part. It's getting more and more steep negative. So notice it's plotting points down towards infinity. As it goes to vertical slope, it's going down to negative infinity. As I go this way, it's getting more horizontal, so the slope is getting closer to 0, but never will really quite reach 0 because it never really quite gets horizontal here. And as I flip across here, these are really large negative slopes, and as I move it across here, it gets less and less steep and closer to 0, so the y values tend towards 0. So this is actually the slope function. Okay, so that red graph represents the slope function. If I do the definition of the derivative on 1 over x, I get negative 1 over x squared. And if I were to graph negative 1 over x squared, I would end up with this red graph. So the pattern that I get when I actually plot the slope values, I'm going to get the function, and that function looks like it's a negative 1 over x squared function.